Welcome back to my channel. I'm Brian Kafke, and we're continuing the Master Databricks and Apache Spark series, Lesson 38, Scala, using RDDs, better known as Resilient Distributed Datasets. Let's jump in. But before I do want to say all statements in my videos are my own and no one else's. I also like to ask anybody out there who would like to help support me in my mission to educate people on technology to consider contributing to my Patreon channel, where you get access to me and ad-free videos among the benefits. Resilient distributed data sets are actually the base data object in Spark, and sometimes it's referred to as the Spark data currency. Why is that, Brian? Why would we call it such a strange name? Well, because what happens in Spark is no matter what you do, you use data frames now, they even have data sets and all these cool things. But at the end of the day, Spark has to convert everything back to RDDs, or resilient distributed data sets, to actually do the work. In fact, originally, you had to work directly on RDDs. You didn't have any other abstractions. The problem with RDDs is that they're black boxes even to Spark. So you did a lot of work. There's much more work to code with than, say, data frames, but you also got a lot worse performance because Spark didn't really know how to optimize what you were trying to do. So some notes in here, feel free to read these. The notebook itself will be posted on GitHub, and I'll leave a link in the description so you can go get a copy for yourself. And I also put a lot of different links in my notebook so that you can follow up and do more research, because I can only really touch on some of the highlights when I'm doing videos like this. One thing I do want to mention is that RDDs cannot be changed. It's called immutable. There are a collection of objects which, once cast, cannot be altered. And that's because there's this whole process that Spark goes through so that it can recreate a resilient distributed data set whenever needed. The idea is it's fault tolerant, right? So if anything happens, it knows how it got there and it can reconstruct it. But if it allows you to change them, that might make that more difficult. So link here to get more documentation on Scala. Now there's two ways we can connect into the Spark environment when we're accessing things. One is called the Spark context, which Databricks automatically gives you an object variable called SC to connect to. And that's actually a little bit more of an older way to connect in, but we'll be doing that when we do RDDs. But you can also use what's called the Spark session. I'm showing you these. You can see not really a lot to see here, but there's an object for each of these. By the way, RDDs are really not often the way you will go after data anymore. The newer abstractions like data frames and data sets are really the better way if you can use them. But there are times when you need to get back and really tightly control exactly what you're doing using RDDs. Now, I do need to talk a little bit about the Scala language. I know quite a bit about Python. I know quite a bit about R. I am not an expert by any means when it comes to Scala. What I typically do is find code that I need that does somewhat close to what I want, cut and paste it into my notebook, and then adjust it to my needs. Usually in Databricks, you can get away with not having very deep, complex Scala code to do things. First thing I want to point out, you see a lot of, is the references to var in Scala versus val. Var is short for variable, and val is short for value. And a var is a variable, which means it can be changed, so it's mutable. And val is really a constant. So once you assign it a value, you can't change it. It's immutable. In this example, we're going to create a var called myvar and assign it a value of 25. Then we're going to create a val called myval and assign that a value of 42. Nothing fancy here, but you will notice that we see this int when it displays the value. It has cast the type based on how we've assigned a value to be an int. Now, what's important to understand in Scala is, unlike Python, it does not use dynamic typing. Once it has a type, it's cast in stone. Now we can change my var, because it's a variable, we can change the value of that, not a problem. We can see we just did it right here. But we cannot change its type. We cannot, for instance, assign a string. You get it right here. Error type mismatch. And it tells you cannot do that. So now we know it's been typed and you can't change it. And that's true of most programming languages when you go a little farther back, like C, COBOL even, Visual Basic, and those languages. Those were strongly typed languages, and so is Scala, because Scala is built on top of Java. What about val? Can we just go here? Let me try to change what we stored in val. And you get an error here. You cannot reassign the value myval because it's a constant. What if I said val myval and then change the type and the value? It works, which tells you that when you use the val or var statement, it's actually going to delete and recreate that object. So just be mindful of that, because if you did a val and then another val later, it will wipe out what you had with the new one. And we can see here we just changed my val, which had been an integer, to a string. Now I want to emphasize here, the key reason that worked is because we redeclared the variable. All right, now we got all that behind us. Let's take a look at creating an RDD of our very own. We're going to use the SC Spark context method text file to load a text file. We're going to load this little Hamlet soliloquy text file. It's going to go into poem_RDD1, and I'll just see whatever it displays when we put that on a line by itself. You can see it goes through here and it read in the text file. Doesn't really tell us much except this is where it's pointing to. Now, there's two things you can do with a RDD. You can do a transformation or you can do an action. A transformation is just what it sounds like. You're taking the data and you're applying some sort of logic on it. But the key thing to understand is, unless you force it to do something, it will do what's called lazy evaluation. It won't actually apply any of the transformations until you force it to. And you force it to by using an action. Let's take a look at this example and we'll kind of walk through it. We're going to take our poem_RDD1 and we're going to do a take. A take is an action. And it kind of makes sense because what a take actually does says, okay, go get me some number of rows from that RDD. And here we're saying we want 3. So if you're going to ask it to actually get 3 rows from the RDD, you're forcing it to take an action. So that's the action. It's going to return that to val poem_lines. And then I'm just going to do a for each loop here to print out the lines. And here you see here, it did just what we wanted. We have the little label here, and then we're just looping over this F. And this is how we can loop over the RDD. Now we're going to recreate poem lines again, but this time instead of a take, we're going to do a collect. What's a collect, Brian? What's the difference between that and a take? A collect is the same as a take, except it's like saying take everything, take all. So collect says bring back the entire RDD. Now, of course, if you're going to do that, you have to be very careful because both take and collect are returning this data to the driver node. And if you bring back too much, you will crash the node and it won't be fun. So here we got the poem_RDD1 collect, and that's going to come back into poem_lines. And we'll do the looping again, and now we'll just get like all the lines in Hamlet's soliloquy, to be or not to be, all the way down. I think it's the full poem. Yeah, it looks pretty long. Now, an interesting thing is that resilient distributed data sets are not held by Spark once they've been used. So you kind of get them, create them, and it throws everything away. It doesn't really retain them. You can change that, and I'll show you in a minute how to do that. But before I do, let's create another type of transformation. We're going to use poem_RDD1. We're going to use the map method, which is a transformation. And we're going to basically iterate over it and get the length, S length. So each row as it comes in is going to return the length. And this is how the format of coding that you're going to say, okay, get every sentence coming in, every line, and then just give me the length back. And that's going to come back into line lengths. And then here we're going to do a collect, and I'm going to do this for each. So what's going to happen here is I'm going to say line lengths, collect the line lengths from above, and then loop over it with a for each and print out the lines. And there it is. I just wanted to show you that what we're doing here is we're just getting all of the line lengths and returning that essentially as an array, or RDD really, of these line. Now I want to show you something else. Map is a very common transformation, and you may have heard things when you hear about things like map reduce in Hadoop, etc. Same idea here. We did a map. Now we're going to do a reduce. A reduce really is some sort of calculation, typically an aggregation that we're running over an RDD. So we're going to take our line lengths here. We're going to say reduce it. And it's got a really weird syntax, but what it's doing is it's passing in each line and then the line after it, and it's doing this accumulation. So what's happening is it says, okay, pass in the first line and pass in the second, and then add the 2 lengths together, because remember, these are line lengths. So it's going to add the 2 together. Then it's going to go to the next line and the next line, and ultimately the end result is it's going to get the total length of all the lines, or the total number of characters that are in the RDD. So when we're done, we end up with this total length, 1374. There's a total of 1,374 characters. Typically, you wouldn't have separate cells in a notebook doing this. You'd probably do it more together like this. I'm going to create my val line lengths, and I'm going to get all the lengths into this RDD object. And then I'm going to take that and take line lengths and do a reduce over it, summarizing the total lengths up here to get total length. And then I'm going to do something I haven't shown you yet, which is pretty cool. I'm going to take line lengths and say persist it. Now, why I'm doing that is because I mentioned before, RDDs get tossed away very quickly by Spark. And if you want to use them for something else, Spark will have to go through recalculating or regenerating it. But if you say persist, you're basically pinning it into memory and saying, hold it there, I'm going to need that again. So we got a same thing as before, line length, but now we've done this holding of the data. What other actions can we take, Brian? What can we do? Well, one other action is a count. Makes sense, right? In order to find out how many elements are in the RDD, you're going to have to do a complete count, which means you got to execute it. So count is an action. You can also do first. So we're doing poem RDD1 first, and that's going to give you the first row to be or not to be. Or you can do max. What's the max? Here we see, oh, with disregard. And here, just to show you, we can also do something kind of arbitrarily different, but we can get the number of partitions. How many chunks of data did this get broken up into? We've got 2 partitions. So we'll do another val. This time we're going to do poem underscore RDD2. We're going to take poem underscore RDD1 and we're going to do a map. This time we're going to create this function, which is going to return each row to lowercase. Concatenating another method to split up all the words. And we know how to split it up by all the words because anything that has a space between it is considered a separate word. Then we'll just take 5 back, meaning we're going to return 5 of these and see what it looks like. And you can see here we get the result array here, right? To be or not to be. Now watch something very interesting. Each line in the poem is a separate array, right? So we go here, that's one array. Then you can see we have another array beginning. Essentially, it's a nested array. Let's talk about something else. We've seen map, but we can do something called flat map. And there's some notes here. But what we're going to do is use flat map to take out that nested array and return it as just a flat single dimension array. So we're doing what we did before, saying RDD map. But when we do this to lowercase, then we're going to do flat map, which essentially is flattening out the dimensions. In other words, returning a single dimension. And then it's going to come back here and split it up. And if it works correctly, I hope it does, it should just return a bunch of words in an array. We can see here I did a take 15, so I'm not going to see the whole thing, but we can see that's what it did, right? Array, and then it just goes on, and it doesn't have array anymore. It's not a nested array. Another thing we can do with RDDs, creating RDD3 here, we can do distinct, which means if you had duplicate values, for instance, it's probably there a lot, right? Those kinds of things will be now dedupe. And so you can see that's what it did there. Finally, a really important thing to be able to do is not return the entire RDD. As I mentioned, if it's a really big RDD, you could crash your system, crash the cluster, if you take too much data back. So a better idea is to do some sort of sampling. We saw take, but take is probably not going to be useful in many cases because you're going to always be getting like the beginning rows, right? Whatever it gives you, 3, 4, 5. If you're doing machine learning, something that would probably be a lot more effective is to do a sampling of the data. So this is kind of a big sample because we have a small data set. What we're going to do is take poem underscore RDD3. We're going to take a sample of it. We're going to take half of it. And then we're going to use what's called a seed, which says 42. It could be anything, but 42, as we know from Hitchhiker's Guide to the Galaxy, is the answer to life, the universe, and everything. So we're going to use that. And we're saying without replacement, right? So that's what's going on there. Once we get that, that's returned to poem underscore RDD3 underscore sampled. Then we can print out how many rows did we get back versus the original rows we had. So the sample that came back shows 127. The full version is 256, which, technical trivia, if you have 8 bits and you fill them up, you get 256. So that's all on RDDs. There's a lot more you can do. I gave you the links. Feel free to go back and check it out and learn all that. But as I mentioned, RDDs are really fastly becoming a bit deprecated by Databricks and Spark in general. Data frames and data sets are usually a lot more intuitive to use. They offer a lot more optimization features, and you can do a lot of things with them. So you probably won't be seeing RDDs being used as much as we move towards the future. But they are good to understand. You do need to know about them. You'll probably get questioned in interviews about them too. So good to know. So RDD stands for Resilient Distributed Data Set. And we talk about transformations and actions. And let's see if you remember, transformations, they make changes, they do things over the data, but only actions make them do the work. That's it for me this time. I hope you like this. Please like, share, subscribe, leave comments. I'm always happy to see those. And until next time, I'm pulling for you. We're all in this together. Thank you.